Have you ever wondered what would happen if you fell into a black hole? Would you be stretched infinitely, trapped in some endless dark void, or could there be something beyond? Perhaps even a path to another universe. Before we dive into the mysteries of black holes, let's rewind a bit and understand how this fascinating cosmic phenomenon even became a part of our reality. It all starts over 100 years ago with Albert Einstein. In 1905, Einstein introduced something that changed our understanding of time and space forever: the special theory of relativity. This theory suggested that time isn't as constant as we thought. In fact, time can slow down if you're moving fast enough, close to the speed of light. Imagine you're in a spaceship, traveling at nearly the speed of light. To you, everything inside the ship seems normal. Clocks tick, and time flows naturally. But if someone were watching you from Earth, they would see time running slower for you. You would age more slowly, while on Earth, years would pass. This mind-bending concept is called kinematic time dilation, and it's just the beginning. A decade later, in 1915, Einstein expanded this idea with his general theory of relativity, and things got even more interesting. Einstein proposed that not only speed, but gravity itself can warp time and space. The stronger the gravity, the slower time moves. You might have seen this concept visualized in the film Interstellar, where time on a planet near a massive black hole passed so slowly that 1 hour there equaled 7 years on Earth. To explain how this works, Einstein asked us to picture the universe as a giant fabric, what we now call space-time. This fabric bends under the weight of massive objects, like stars and planets. The more massive the object, the deeper the bend in the fabric. And near black holes, that bend becomes so extreme that time itself slows to a crawl. But gravity doesn't just warp time, it also affects light. Einstein's equations suggested the possibility of objects so dense, with gravity so intense, that not even light could escape. But back then, this was purely theoretical. Even Einstein himself found it hard to believe such things could really exist in the universe. Fast forward to the 1960s, and things began to change. Scientists working with Einstein's equations started to realize that black holes, these mysterious objects that could trap light, might not only be theoretical. By 1967, physicist John Wheeler had popularized the term black hole, and the hunt for real black holes was on. But what exactly is a black hole? Despite its name, it's not a hole in space. Black holes are born from dying stars, stars much more massive than our sun. When these massive stars run out of fuel, they collapse under their own gravity. In some cases, the collapse is so intense that the star's core compresses into an incredibly small and dense point, a singularity, surrounded by a boundary called the event horizon. Once something crosses this boundary, not even light can escape its pull. From the outside, the black hole appears as a pitch-black sphere. So, what types of black holes are out there? The most common are stellar black holes, formed from collapsing stars. Scientists estimate there could be millions of these scattered throughout our galaxy alone. Then there are supermassive black holes, monsters that are millions, even billions, of times more massive than the Sun. These sit at the heart of most galaxies, including our own Milky Way, where a supermassive black hole called Sagittarius A* resides. There's also speculation about smaller, hypothetical black holes known as primordial black holes, which could be as tiny as an atom, but as heavy as a mountain. And some scientists believe there could be intermediate black holes, sized between stellar and supermassive black holes, though these remain unconfirmed. When you think of black holes, you might picture a swirling vortex pulling in everything around it. But in reality, black holes don't behave like cosmic vacuum cleaners. Stars and planets can orbit around black holes just as planets orbit the Sun. And unless you get too close, you're perfectly safe from their grasp. However, things get really interesting near the event horizon, the boundary of no return. Surrounding this horizon is often a glowing, swirling ring of gas and debris known as the accretion disk. As matter gets pulled toward the black hole, it accelerates to incredible speeds and heats up, glowing brightly in the process. This glowing disk is one of the few ways we can detect black holes, as the black hole itself doesn't emit light. In fact, in 2019, scientists captured the first ever image of a black hole, revealing a glowing ring of gas around a shadowy center. The image confirmed decades of theory and gave us a glimpse of a supermassive black hole located in a galaxy 55 million light-years away. But what happens if you fall into a black hole? Would you be stretched like spaghetti? As some theories suggest, it's likely that the immense gravitational forces would tear you apart long before you reached the singularity. And once you cross the event horizon, there's no coming back. Time and space, as we know it, break down. Inside the black hole, things get even stranger. In theory, light itself is bent and trapped by gravity in such a way that it could loop around endlessly. This means that theoretically, if you were somehow alive inside a black hole, you could see the back of your own head. And as for what lies at the very center, that's the ultimate question. The singularity at a black hole's core represents a place where space and time become infinitely curved, and the laws of physics as we know them cease to function. Could be a gateway to another universe. Or does it simply mark the end of everything? We just don't know. While black holes might sound terrifying, there's no need to worry. Despite their fearsome reputation, black holes are just another part of the cosmic landscape. And as long as we keep our distance, we're in no danger of being sucked in. Instead, they remain one of the most fascinating mysteries of the universe, a place where time, space, and reality itself are stretched to their limits. With that said, thanks for watching, and until next time,